Okay, now we're on 37, and on this, the directions say find the function's absolute maximum and minimum values and say where they occur. And we have x to the 4/3 from -1 to +8. So on this one, you don't have to draw your graph. You just will need to figure out your absolute minimum and maximum and critical point. Okay, so what we start with on this is x raised to the 4/3. So it looks like this, and we want from -1 to 8. So we're going to have to expand this part of the window. I'm just going to estimate 50. That's too high, but that'll do. Okay, so at -1, let's find out our endpoint. So go to your table. It's probably the easiest method. And at -1, it's 1. And at 8, it's 16. And then we have a few symmetric points in here, and looks like your minimum would be 0, 0. So I got that from symmetry on the table. So this would be your symmetry. And so I know this is the lowest point or minimum. If you don't feel comfortable with doing it that way, and sometimes it doesn't show up in your table, you may want to actually just use analyze graph and go to the minimum, which is there, and trap it. The lower bound, it just means the left, and the upper bound means the right. And there's the 0, 0. Okay, so that's the most important part, and then we have our paragraph. So this one, our f prime of x would be 4/3 x to the 1/3, and we have a critical point at x equals 0, and then we have our values. F of -1 is 1, f of 0 is 0, f of 8 is 16, and the absolute max is 16 at x equal 8, and the absolute min is 0 at x equals 0. Okay, so our next one is 39, and we have g of theta equal theta to the 3/5, and we're given negative 32 less than or equal to theta less than or equal to 1. So our derivative be 3/5 theta. So just as a side note, 3/5 minus 1 is the same as 3/5 minus 5/5, and so that's negative 2/5. And so that'd be your derivative. So remember on this, think of it as x to the 3/5. So it looks like that. And we want the value at negative 32. By the way, go ahead and change this to ask mode, independent to ask. In the table, change independent to ask, because that'll be quicker than just scrolling. And we want it negative 32, and we get negative 8. And then we push 1, and we get 1. And this is a turning point, which is at 0, 0. I'm going to change this back to auto. Okay, so here you can see that 0, 0 is a turning point. So that's where it changes from concave up to concave down. Or if you want to think of it as concave left and concave right. Okay, so what we have for this is a critical point is at theta equals 0, and then we have our g of negative 32 equal negative 8, g of 0 is equal to 0, and g of 1 is equal to 1. And in this interval, our highest point was, let me get rid of the table, Control T. Our highest point was up here, and our lowest point was over here. So our absolute max is 1 at theta equal 1, and then the absolute min is negative 8 at theta equal negative 32. So that's what you need for 39. Okay, 41. On this one, we have determine all critical points. And your function is y equal x squared minus 6x plus 7. So determine all critical points for each function, and there it is. So this one actually might be easy to factor, but let's not get sidetracked on that. It's actually not. You need a -1 and a -7. But anyway, let's not get sidetracked on that. Let's do our derivative like we did before, and we get 2x minus 6. So your 2 comes in front, and so we have 2x, and then the part with the linear term just turns into the coefficient. So then what you do is you say 2x minus 6 equals 0, so you add 6, and you get 3. So the critical point is x equal 3. If we were to graph this one, we'd have x squared minus 6x plus 7. And at 3, okay, if we go to our minimum, it's 2.999, let's just say 3, comma -2. So from the graph, shows -3, sorry, +3, -2 is the minimum. And so 3 would be your answer. So that looks like a shortcut if you don't want to take your derivative and set it equal to 0 and solve. Or graph it. Those would be your directions. Graph it and find the min or max. Okay, so there's 41, 43. This one, it's f of x equal x and then 4 minus x to the third. Okay, on this one you're going to have to use your product rule. So f prime of x would be basically u times v prime plus v times u prime, where you call this u and this v. So your u is x, your v prime. Okay, so you take your 3, put it in front, you copy down the exact same thing, 4 minus x, and then decrease the power. Then take your derivative of the inside, which was -1. So that's your u v prime. So this really is like -3x 4 minus x squared. Okay, and on the other one we have v times u prime. So this is your 4 minus x cubed times the derivative of x is 1. Okay, so that's your product rule. Now what they want you to do is factor out your GCF, which is 4 minus x squared. So 4 minus x squared, and you have -3x plus 4 minus x. So this was to the third power, and so you could put parentheses around here, but since it's a plus, parentheses don't matter. So think of 4 minus x squared times 4 minus x is 4 minus x cubed. So that's how that works. And then you just combine your like terms, and so this would turn into 4 minus x squared. Then you have negative 3x minus x would be negative 4x. And they want your positive term first, so you have 4 minus 4x. Okay, so now what they're going to do is factor out a 4 from your first term. So what I want to do is just rewrite this and then factor out a 4 from your first term. So this would turn into 4 times 1 minus x, and then you're multiplying by 4 minus x squared. So you're not factoring out from both terms. You can't do that. You're just factoring out from one of them. And so then we want to set that equal to 0. And so you have 1 minus x equals 0, so 1 equals x. And four minus x squared equals 0. Okay, so what we need to do on this is start this way, but we have a 4 in front. And so this is 16 minus 4x squared equals 0. I guess either way we have x squared is 4. What we're going to do on this one is graph it. And it looks like at 4 it's going to change direction. Yeah, sure enough it did. Okay, so let me not do it this way, and this is your derivative, and from the graph you can see that x equal 1 and x equal 4 are critical points. Okay. This one we have y equal x squared plus 2 over x. So first thing is take your derivative, so that'll be 2x. By the way, let me just rewrite this. And this turns into minus 2x to the negative 2, so that's 2 over x squared. Alright, so there's your derivative. Then they want you to get a common denominator. And so x squared is going to be your denominator. So we've got to do 2x times x squared. So that really is 2x cubed minus 2 over x squared. And we want to set that equal to 0. And so you have 2x cubed minus 2 equal to 0. Let's factor out a 2. And divide by 2. So then x would be 1. Like basically the x would be 1, and then the cube root of x cubed is x, and that's also 1. So in other words, you are going to have a critical point at x equal 1. The other thing to note about this one, we have a divide by x, and so if you're dividing by 0 is undefined, so that means 0 is not in the domain. So it couldn't be a critical point. So basically your domain would be negative infinity, 0, parentheses, union, 0, infinity. And so this is your only critical point. We've done several of those, and so now, let's see. Okay. The next one is 47. Which has y equal x squared minus 32 squared of x. So on this one, you take your derivative. Well, first, just rewrite it as x to the half. And then your derivative would be 2x minus 32 times a half, x to the negative a half, and then multiply by 1. So this really ends up being 2x minus 16 over the square root of x. So then they want you to get a common denominator. And so we have 2x square root of x minus 16. And that's really 2 to the x to the 3 halves. So think about the first one being x to the 2 halves, and then square root of x is x to the 1 half, and add your numerators, and so you get 3 halves. and we're again going to set that equal to 0. And so you have 2x to the 3 halves minus 16 equals 0, because when you multiply by that, your term goes away. We're going to bring the 16 over and divide by 2, which will give us 8. And so we need the cube root of 8 squared. And so that's going to be 4. The cube root of 8 squared. Okay, now if you need it, the extra part would have been, if you have x to the 3 halves equal 8, then you need to raise it to the 2/3 to cancel them. And that's where I got the cube root, because your denominator is your root and this is your exponent. So you don't have to write that part, but you do end up with 4. And so that's one of them. The other one is probably at 0, because both have x in them. Let's just double check from the graph. Yeah, 0 is 1. X equals 4 and x equals 0 are critical points. So you use a couple of different methods on this one. If you need to, put square root of x equals 0, so then x is 0. So that's how you get your other critical point. Okay, next we have 49. And on this one we have y equal x cubed plus 3x squared minus 24x plus 7. And so first step was take your derivative. So we get 3x squared plus 6x minus 24. And then from there, they want you to factor out a 3. And then they want you to factor that if possible. And we're trying to get a -8 but a +2, and 2 times 4 would work. And the 4 term has to be positive because our middle term is positive. So then you just have to set each of these equal to 0. And so the critical points are x equal 2 and x equal -4. Okay, 51. Okay, so on 51, we have y equal x to the 2/3 x plus 2. So on these, what we want to do is find the critical points and the domain endpoints, then find the value of the function and identify the extreme values, absolute and local. So basically the works, so to speak. And so for this one, you need to use your product rule, calling this u and this v. Let's see, y prime would be v times u prime plus u times v prime. So we get x plus 2 times the derivative of x to the 2/3 would be 2/3 x to the -1/3. And then we need plus x to the 2/3 times the derivative of x plus 2 would just be 1. So then we want to rewrite that as 2 times x plus 2 over the cube root of x plus x to the 2/3. Do it like that. Okay, so now they want you to get a common denominator. And here we're going to distribute. Oops, square root. Okay. So we have that exact same term, and then we're multiplying by this to get a common denominator. That looks in a weird form, so I'm going to change this to x to the 2/3 times x to the 2/3. And I think if you do that, that's going to help you a little bit. So we have like basis, so you add your exponents. And so we get 2x plus 4 plus x to the 4/3 I just noticed my mistake. Okay, everybody makes mistakes. I have a 3 that should be in my denominator. And so that throws things off a little bit. I'm going to have to fix this. Okay. So then the next part is, I believe we're going to just change this to be 2x plus 4 plus x plus, like that. And then this would be 3x plus 4 plus x to the 1/3. This one I'm kind of getting stuck on. It's kind of weird. We were really good up to this point. So to this point we were good. And let me just show you what I have to work with. So over here, all of the others showed you extra steps and everything, but then just says 5x plus 4 over 3. So not really sure about that part. So let's keep it in the unsimplified form and not do this part. So keep it unsimplified, because this doesn't seem to buy us anything, and we know that part's right. Okay, so what we need to do then is graph it. And so you have a maximum at negative 0.7999. Well, I'm just going to put x equal. And so that's going to be x equal negative 0.8, which is the same as negative 4/5. So x equal negative 4/5 is a critical point. And the other one is at 0 because that's where it changes direction. So what we're going to end up doing is making a table. We're going to have a critical point with x equal negative 4/5 and x equals 0. The derivative at that point, since it's a maximum, it's 0. And on this one it'd be undefined. Since it's not a, well, yeah, it's a minimum, except in this case it's a sharp turn. It's not just a maximum or minimum of a parabola. So that one's going to be undefined. And so this is a local max and a local min. Looks like they want the value also. Okay, this is the title, extreme. The value part, the value of x equal negative 4/5 is negative 1.034. We found that right there, 1.034, and the value of x equals 0 is 0. Okay, so make sure you get that information, and that's 51. Okay, so 53. 53 is our last one. I decided not to stop the video, and you can just pause it and continue as you need to, but I don't want to make a separate video for one question. So 53 is y equal x the square root of 4 minus x squared. So this is equivalent to x 4 minus x squared to the 1/2, and so that's u, that's v. So your derivative would be v times u prime plus u times v prime. 4x minus 4 minus x squared to the 1/2 times 1 plus x times 1/2, and then 4 minus x squared, and then negative 2x. And then we have to combine those. The 2's cancel. So on this one, I brought down my half, I copied this down, but I need to decrease the power. So this would look like that, and now get a common denominator. And so you do that times that, which would just be 4 minus x squared. And then plus x squared. So here I had a negative 2x, and I forgot to bring my negative sign over. Okay, so it's like that. So this turns into 4 minus 2x squared over the square root of 4 minus x squared. Okay, so all that work is correct now, and now we're in the home stretch. We just need our critical point, our derivative, our extremum, and our value. Okay, so we need to graph this. What we're doing is graphing the original. So basically the original graph would look like that. And so first let's go to our table, and it only works from -2 to 2. So those are the endpoints, and then notice this one is there. Let's see. Analyze minimum. Okay, so our minimum is at -1.41. So that would be negative square root of 2. And on our other one, it's symmetric, so that'd be positive. So those are the 4 critical points. And our derivative of the boundaries would be undefined. And this one is a local max. And this one is a local min. And our values were 0 for both of those. So that's from your boundaries. And then the other ones, it's just the derivative like that. It's not a weird cusp or anything, so the derivative would be 0. And this is a minimum, this is a maximum, and it's -2 and 2. And you can see that your y value is -2 from there. And then let's go ahead and do the last part. Analyze maximum from here to here is positive square root of 2 comma 2. Okay, so make sure you get your derivative steps, and then this is your table. And that would be the end of 4.1.